Good afternoon, everyone. Welcome to today's edTalk on understanding agentic AI, developing autonomous agents for real-world applications. We are thrilled to have you join us for this insightful session. For all of those who are able to hear me properly, please give a thumbs up so that I can know. Great. Before we dive in, a quick note. As a token of appreciation, attendees who stay until the end will have a chance to win an Amazon voucher, so be sure to stick around. Now, it's my pleasure to introduce our esteemed speaker, Siva Prasad Valluru. Siva is a seasoned expert in generative AI and MuleSoft. With over 20 years in IT industry, his extensive experience includes collaborations with leading organizations like Motorola and Tech Mahindra. As a certified instructor for MuleSoft and Pivotal, Siva has significantly contributed to Spring Framework and is renowned for his deep understanding of technical framework, enabling participants to effectively apply their learnings. So, without further ado, let's dwell into today's topic. Siva, over to you.
Thank you. Thank you, Estos. Let me share my screen before I start.
Great, Siva. Your screen is visible, and so are you.
Thank you. Thank you for confirmation. Hello, good afternoon, everyone. So briefly, let me tell you what is the agenda, what is the plan for next 2 hours, and then I'll take a forward. What is the main agenda I will talk about? So the thing is, we'll understand about what is this agentic AI. So many of you might have understood about or used ChatGPT or GPT, right? But what we can do with ChatGPT? When I saw ChatGPT initially, I thought it's just like chatting, what all we can do. So in this webinar, you are going to understand about what is an LLM, what all we can do with a large language model like GPT, how to use LLM as a reasoning engine, and there are multiple prompting techniques. We'll understand about a very interesting prompting technique called as React prompting. And then we'll also understand about what are embeddings and vector stores. We'll understand about RAG, Retrieval-Augmented Generation. And then we will see how to build autonomous agents and what are the various frameworks for building autonomous agents. There are multiple frameworks like Crew AI, AutoGen, LangGraph, Llama Index, etc., LangChain, etc. I will show you in this 2 hours almost. What I will do is I'll spend almost 1.5 hours for my demonstration, and last half an hour, 20 minutes to 30 minutes, I'll keep for question and answers. Okay. So let us get started without wasting any further time.
That is great, Siva.
Yeah, thank you. So what my way of delivery is, I don't like presentations. I want to show you everything on screen by drawing, and I want it to be like interactive session. Maybe if you have questions, what you can do is you can write your questions in the question and answers part, where I can answer whenever I get some time. Whenever I finish some logical part, I'll see the question and I'll answer you. Okay. Okay, let us get started. So I hope everybody has used ChatGPT. Now, the first question in the mind is, what is difference between GPT and ChatGPT? Most of the people don't understand the difference. In this session, by the end of this 2 hours, you will get a very good clarity about what is agentic AI, what all we can do with agentic AI. I will show you one demo of a small agent for a real-time scenario. Okay, so keep tuned. Yeah. So what is difference between GPT and chat GPT? Let me try to understand. GPT is basically a large language model. So we are not going to talk about how this model has been trained. It is a trained model. So you might be knowing in AI, there are different things like machine learning, deep learning, and we have generative AI. By using machine learning and deep learning, we create models and we train them. And in deep learning, there are multiple architectures like deep neural network architectures. One of the popular architecture is transformer architecture. It is a neural network architecture. So in GPT, T stands for transformer, generative pre-trained transformer, generative pre-trained transformer. So that means this GPT is following transformer architecture, and it is a trained model. It has been trained on huge amounts of data, and it understands our natural language. So as it is trained, as this model is trained on large amount of data, we call it as a large language model, LLM. Okay, let us treat this LLM as a black box. Right now, for our discussion, we don't want to go and discuss about how this LLM has been trained. Assume that we have a trained model. Now it is an expert. It knows about a lot of things. Whatever questions you ask, it will actually answer. There are a lot of LLMs from OpenAI. There is a LLM called as GPT, of course. There are a lot of other LLMs like Claude, Gemini, Mistral, etc. Let us not confuse. Let us focus on only what is this GPT. This GPT is a model from a company called as OpenAI. Okay. They have developed this model. They have trained this model, and they have exposed this model as an API. So we have something called as OpenAI API. If you want to talk to this GPT, what you can do is you can write some code and make an API call and send your question. The API can give you the answer. This API internally invokes the GPT and it will give the answer. Okay. So till now, we understood GPT is a model from OpenAI, and OpenAI has exposed an API. We can consume it. Okay, fine. Now we understood about GPT. What we can do, we can ask a question over REST API call. We can send a query and we will get the answer back. It is a REST API. But then what is this chat GPT? They are different. Chat GPT is a web application or a mobile application. It can be a front end, I can say. Okay. And behind the scenes, this chat GPT will be making calls to GPT model. There are multiple GPT models. Okay, fine. I can say that this chat GPT is a agentic application. Okay, I'm slowly introducing you to agentic. This chat GPT is an agentic application. Okay, what do I mean by an agent? I will tell you. Okay, so understood the difference about GPT and chat GPT. GPT is a web application which is internally having a lot of agents. It is an agentic application. It has a front end, a mobile front end, a web front end, and it internally uses GPT. So in chat GPT, I think everybody might have chatted with it. If you send a question, what will happen? This chat GPT web application, through browser, you actually chat, right? The request will go to the chat GPT backend web application. And this internally makes an API call, get the response, and that is what is displayed on your chat box. Basically, it is acting like a front end. And internally, it has a lot of agentic applications. It is using agents to talk to GPT. Okay, that is at a high level. Fine. Now, what if I want to develop a agentic application on my own? Okay. Now, is it okay? Is my voice still echoing? What about you, Astush?
It is fine.
It's fine? Okay. Thank you. Thank you. So fine. We'll continue. Okay, fine. If I want to write my own agentic application, what is an agent? As a layman, I want to understand what is an agent and what all I can do. So let it be a interesting discussion. I'll take you from simple examples. I will not use big jargons, but by the end of 1.5 to 2 hours, you'll understand all the jargons used in this industry. Okay. So let me make it very simple and interesting. What is an agent? Okay. Now, let me just tell you. This is a large language model or GPT. It is a model and API is exposed. This is OpenAI API. Okay. Fine. Now, what I can do, suppose if this is me, I can make an API call and ask a question. I'll get the response. I can say that this GPT model is like an expert. It knows about everything because it has been trained on huge data, and it can give me reasoning as well. We can call this as a reasoning engine. Okay, this is very interesting. What is this reasoning engine? As it is trained on huge data, it identifies patterns in the data and it can answer your questions with reasons. I'll tell you with an example. If I ask any question, instead of directly giving me the answer, it will tell the logic behind answering also. Right? It is like an expert human being, but it's not a human being, right? Because it has been trained on a lot of data. Now, how can I leverage this reasoning capabilities of LLM? Let me tell you a simple thing. Now, this is my large language model. It knows about a lot of data, but it doesn't know about the data in my database. Let's assume that in my organization, I have a database. Assume that I am working for an e-commerce application like Amazon or so, which has all the data about orders, customers in their database. Okay. Now, let's act that I'm a person, not a program. I'm a person and I want to get some information about my e-commerce application answered from LLM. Now, I can ask a question to LLM. Hey, LLM, tell me how many users are there without shipping address? There might be some customers in my database, but they might have not configured some shipping address. I want to ask this question. How many users are there in my database without shipping address? But is this LLM trained on my data in database? No, it cannot answer. But it is an expert. It can help you with answering. Okay. Now, what we need to do is we need to prompt the LLM in such a way that it can answer. There are multiple prompting techniques. One of the popular prompting technique is REACT. REACT. It stands for reasoning and action. So in your prompt, you should ask the LLM to give the reasoning and then tell what is the action. Okay. So let me actually think as a person and let me just show you how to actually prompt LLM using this React prompt and get answers from the LLM about my database. Okay. Now, one thing before I go ahead and show you this React prompt example, I'm a person and I have access to this database. And maybe I have some tools which can query the database. Assume that I have some Python code, one Python code to actually query the database, get all tables in databases, etc. Assume that I have some tools. I'm a dumb person. Okay, assume that I'm a dumb person. Dumb means I don't have mind to think, assume, but I have an expert. So how can this dumb person leverage this expert to get the queries answered? That is the interesting discussion. I'll make it very interesting. Just listen, okay? I'm a dumb person. But as a dumb person, what I can do is, if somebody tells me, do the step 1, step 2, step 3, I'm good at doing step 1, step 2, step 3. Okay. So let us see how I can actually leverage this LLM. And I have some tools. If the LLM tells me to execute a tool, I can execute it and give the response back to LLM. So with abilities, let me show you how to write a simple prompt. A prompting technique name is react, reasoning, and acting. Let me show you a simple example, okay? Let me open my browser. Yeah. Actually, I'll go to a simple platform.openai.com. Everybody knows ChatGPT, right? I don't want to use ChatGPT for right now. I don't want to use queries using ChatGPT, but I will use something called as Playground from OpenAI. Here I can try out my prompts. Okay. Here I'm in my Playground. I have already logged into my account. And now I can write some prompts. But before that, you can see I can select what GPT model I want to use for prompting. There are multiple GPT models. This is GPT-4o is a high intelligent model. Okay, let me use that. Then here I can configure some things related to that. I will just tell you my prompt. I will just copy a prompt which I have and I will explain you. Just let me copy the prompt, whatever I have. The same scenario, whatever I told you. I will open a notepad and first explain you that prompt. Yep. This is a prompt which I'm going to use. This is an example of a React prompt. So I will prompt the LLM with this. Answer the following questions as best as you can. You have access to following tools. The tool name is list tables. I'm just describing about my tools. This returns all tables in a given database. Another tool is run SQLite query. We can use it to run an SQLite query. And these are the four tools. My describe tables, which will take table names. And given a list of table names, it returns the schema of those tables. Crawl web is another tool I'm saying, useful for when you need to browse the web. So I'm telling in the prompt, you have access to following tools. These are the tools and their description. And I'm asking, use the following format while responding. First, there should be a question. I'm saying the input question you must answer. Then I want reasoning also, right? Whenever answering, I don't want direct answer. I want reasoning or thought behind this answer. So here I'm saying, after question, you should give me your thought, what you should always think about. And after thinking, you should tell me what is the action to take. The action to take should be one of this, either list tables, this is a tool name, run SQLite query, or my describe tables, or crawl. So action should be any one of them, I'm saying. And action input, what is the input that should be given to the action? For example, if I say run SQLite query, it is asking me to run this SQLite query. What is the query to be given for this? Right? That is the action input. And then after action input, the observation should contain the result of the action. And I'm saying this thought, action, input, observation can repeat n number of times. This can repeat n number of times. And finally, once the final answer is done, it should say the thought, I now know the final answer and the final answer. So I am telling the LLM to respond in this format. Begin. The question is, how many answers are there without shipping address? This is my query. Actually, the LLM does not know any information about my database, but I told that I have these tools, and I told that use this format while answering. Now I'll ask this question. Okay, let me just give this prompt in the playground. Here I can give the prompt. Okay, but before I actually run this prompt, I want to tell you, once I give that question, what should come after question? Thought. It should give the thought, and the LLM will tell what is the action to be taken and what is the action input. But who should execute this action? Me, right? I'm actually a person, a dumb person, and this LLM is an expert. Whenever I ask a question, LLM will respond. LLM might respond and tell, okay, what is the action to be done? Maybe invoking a particular tool. Now, it's me who has to execute the corresponding tool and send the result of tool invocation as an observation. Then LLM will tell what is the next action. This can go on multiple times. Okay. So what I want is, whenever LLM is responding with observation, I want the LLM response to be stopped, because it is me who has to give the value for observation. Okay. So what I will do is very simple. Here, when configuring the model, there is something called as stop sequences. When the LLM should stop, whenever the response contains observation, in the response, if there is observation, it should stop. So I said stop sequences is observation. Now it is going to be interesting. Let us see this conversation between me and the model. I selected, I want to talk to this GPT-4o model. Okay, let me run this. Hey, it's giving. My question is, how many answers are there without shipping address? The assistant is responding. It is giving its thought. To determine how many users do not have a shipping address, I need to look at the database that contains user information and shipping address. I should first list the tables in database to identify the relevant tables. And it is asking me, action to be done is list the tables is the action, and the action input is database name. So it is asking me to do this action, list tables. So as I said, I have a tool called as list tables. I have to execute that list tables and give the response as an observation. So what I can do is, let's assume that I have actually fired that query, and I'll give the observation. So I got this response. It is asking me to execute this action by passing this input. I'm a dumb person, as I said. If I was given some actions to be done, I can do it. So I will execute this by passing this input, and I will give my result as an observation. Here I'm giving observation, and I'm continuing my chat. I'm telling these are all the tables: users, addresses, products, cards, orders, order products. Okay. Now I gave my observation. Now you can see the response from assistant. Now it's giving its reasoning again, the thought. I need to understand the schema of users and addresses table to determine how the user information might relate to shipping address data. So it's asking me to do one more action. What is the action name? My describe tables. Pass these table names. So it should describe the tables. Okay. Assume that I have executed the tool and I'm giving my observation as a response in the chat. Here you can see my observation. This is the schema. These are the two schemas. This is users table schema and this is the addresses schema. Okay. So now again it is saying the thought. The tables include users table with user details table and an address table that associates addresses, blah, blah, blah. Now it is asking me to execute an action called as run SQLite query and pass this query as an input. Okay, now assume that I'm a dumb person. Again, I know how to execute that query by executing the tool. Assume that I'm going to give my observation. Just this is the result of execution of the query. I'm sending my observation. Now, see the assistant is saying thought. The result indicates that there is one user without a shipping address. So final answer is there is one user without a shipping address. So now in this example, we understood that LLM is acting as a reasoning agent. It is answering my questions with reasons and it is guiding me to and telling me what actions to do. It is reasoning and telling me what actions to do. This kind of prompt is nothing but React prompting, and I showed you how I can use React prompting technique to leverage the reasoning capabilities of an LLM, and we understood how this LLM can be used as a reasoning agent. Good. For a dumb person like me, the expert LLM is able to help to get answers for my queries. Good. But here the problem is I have to sit and send messages to LLM. LLM will tell me to do some actions. That means executing tools. I have to respond by sending my observation. Oh, do I need to manually do this? A lot of steps are there, right? Do I need to manually do this? Oh, I'm a very busy person. It will be good if I can hire an assistant on behalf of me who can do all this, right? Okay, let me just reframe this. This is my LLM and this is me. Instead of me exchanging messages with LLM, I will have in between an assistant. Okay. So what I do is for this assistant, I can tell, hey, these are my tools. For this assistant, I'll give all the tools like whatever I described. A tool called as list tables, run SQL query. You can think of these might be some Python functions or whatever that can be executed. So for my assistant, I will give the tools. And also what I will do is I'll just invoke the assistant. Hey, assistant, this is my query. How many users are there without shipping address? Now this assistant will use React prompt, send the prompt to LLM. LLM might respond with actions. The assistant may invoke a tool, whatever is told by LLM, respond with observation. LLM will give next thought, maybe again executing another tool. Assistant will execute the tool, send it back. This can happen n number of times and finally we'll get the result, right? So the LLM can take a decision. Again, here the important thing, it can take a decision based on the observation provided by the assistant. This, you can think of this as a piece of code. Assistant can be piece of code, whatever I write. With whatever observations the assistant is giving, LLM can take a decisions. It can do reasoning, it can take some decisions and can guide the assistant to do what to do next, right? So if I can somehow write this code, what all I can do is I can just delegate my query to assistant. Assistant will talk to the large language model on my behalf and give me the final answer. Very good, right? I don't need to sit and chat. I'll just give my query and I'll get the response back. Okay. Now, another name for assistant is nothing but agent. These terminology, agents and assistant, are used interchangeably. So we understood what is an agent. I can now define agent. Maybe I'm using simple words, right? Without any jargons. Okay, let us try to understand. Let us get more understanding. Let me try to define what is an agent. Agent is nothing but a piece of code for which we give tools. What are you can think of tools maybe as some functions or some objects within our code. So agent is nothing but set of code, piece of code for which we give tools, we give access to the LLM, and we give a prompt. So agent is nothing but a piece of code which will take the prompt, have tools, can talk to LLM, and give me the desired output. That is nothing but an agent. It is a piece of code which can act on your behalf, right? I hope now you got the clear idea. You're able to visualize. For me, whenever I say something, if you can visualize it, I hope I'll be successful. Can you now just give your thumbs up if you are understanding and are you liking this way of explanation? Just give a thumbs up. Yeah, thank you. Thank you. Oh, good, good. So I'll explain you by the end of this 1.5 hour, another 1 hour or so, you'll understand what all we can do by leveraging this large language models like GPTs. Just be tuned with me. Right now, we just understood what is an agent. Okay. What I want to do is, this is the LLM again. Okay. LLM, it is an expert. It can answer any queries. It has been trained on huge data. But in my organization, I have some organization specific data, maybe in some PDF documents, or maybe in .text documents, or maybe in .csv. I have a lot of organization specific data. Can I say that, okay, maybe I have my database as well, where I have my data. These are my organizational assets. And this LLM has not been trained on this. Okay. Now what I want to do is, I want to develop an agent which can actually use LLM to answer my questions on my organization specific data. Suppose, let's assume that I have some PDF. In this PDF, there is some data about, let us say, employee policies. Or assume that I am working for an e-commerce website, and for example, let us say Amazon is an e-commerce website I'm working for, and I have PDF which tells about rules, refund policies, refund rules, etc. Assume that I have a PDF which contains refund policies. Okay. Now, to my agent, if I ask, hey, tell me the refund policy. Maybe there might be a 30-day refund policy for some items, 1 week refund policy for some different kinds of items, etc. So I can ask a query, hey, I bought a laptop last week and I want to get a refund of it. I want to return it and get a refund of it. Maybe for laptop, the refund policy is different, right? So I want to ask my agent, hey, tell me the refund policy of my laptop. I want to refund. I want to return my laptop and I want a refund. If this agent just sends a query to LLM, will the LLM be able to answer the refund policies of my organization? No, the LLM does not know about my organization specific data. So how can I make my agent to get the answer from my documents. Here I wanted to introduce you to a technique which we use called as RAG. Let me introduce you to RAG in a simple way. RAG stands for Retrieval Augmentation Generation. Okay, what is this RAG? Let me explain you in a simple terms. We have unstructured data, and we want to store that data, first of all, in a database. But can I store unstructured data in a SQL database? No, right? Of course, I can store. Maybe I can create a table and I can have a column called as data, and I can store all the data in my documents in this column. But that is not the purpose. Some unstructured data. I want to store the data in a database which can actually store unstructured data and supports semantic queries. Okay. Semantic queries. What do I mean by semantic queries? What type of database can answer semantic queries? So for understanding this bit of thing, you need to understand about something called as vector databases. What are these vector databases? How are they different from SQL databases like RDBMS, etc.? And what facilities do they provide, right? So let us try to spend some time on understanding what are these vector databases. Once we understand vector databases, I will take you back to the technique of RAG, because retrieval, first of all, whenever user sends a query, my code should retrieve the data from my documents. So if you want to understand what is this retrieval process, very interesting thing. I'll put it in a very interesting way. Actually, this is a little bit of complex topic. I'll put it in a very easily understandable way. Let us try to focus on retrieval part in this RAG. How to retrieve data, how to store the data such that I can do retrieval very efficiently. So for that, we need to understand what are vector databases. How can they support something called as semantic queries? What do I mean by semantic query? I will tell you everything with clarity. Please just listen very carefully. I need your attention. Okay. Let's assume that I have some two words. Sunny day. This is one maybe sentence which contains two words. Or I will use something like bright day. First, let us try to understand this. Are these two sentences, assume that these are two sentences, even though I just have two words. Are these sentences having similar meaning? Are they similar? Meaning wise, they are similar. Is it? But are they exactly same? No, they are not same. The wording is different, but they have similar meaning. Maybe if I ask you how similar are these, maybe I can say 95% similar. A sunny day will be, of course, bright, right? They are 95% similar. So how to make a computer understand that these two words are actually having similar meaning? Computer understands only numbers, or the machine understands only numbers. For machine, it doesn't make any sense what is the meaning of bright, what is the meaning of sunny. It doesn't make any sense, right? So if we want to compare these two things, somehow we have to convert these strings to numbers. Then only we'll be able to compare. Okay. Okay, now I'll make it very interesting. Let's assume that I have some sentence or a string. I want to convert it to an array of numbers. An array of numbers. The numbers I want to be between, let us say, -1 to plus 1. I'll have an array with, let us say, 0.1. Maybe I want to make it very simple. I want to convert this string to an array of size 2, just 2 for understanding, 0.86, maybe 0.35. Okay. How to convert? Again, there are algorithms. We can convert a given string into an array. Okay. Again, let us say this is sunny day. For sunny day, assume that we converted this to an array. These are some hypothetical numbers, not exactly, just I'm writing. And maybe for bright day, I can actually convert this also into an array. Maybe if I use a similar algorithm which can convert, maybe it might be something like 0.881 comma 0.46. Maybe, just answer. So somehow, assume that somehow there are some algorithms. Somehow I converted these strings to arrays. Now what I can try to do is, I can try to plot these arrays in a graph. Okay, let us consider this point in a graph as A and this as B. So maybe this is A. This is A. Maybe here this is 0.86. And on y-axis that is 0.35. Okay, where does B come? 0.81, little here, and 46. Maybe B will come here. Okay, I pointed this on graph x-axis and y-axis because the array size is 2. I plotted them on a 2-dimensional array. Okay, if I can draw a line from origin to this point and to this point, actually I can say that these 2 points represent something called as a vector. Okay, maybe I'm using the terminology right now. You need to understand vector. I hope in your +1, +2, when you studied, you might have remembered what is a vector. Vector is something which has a value and also a direction. Velocity is a vector, speed is a scalar, maybe you would have understood, right? So here you can say if I draw a line from origin with this arrow like this, you can think of this line as a vector. So I can say that these A and B are represented as vectors. What is the size of this vector? It is a 2-dimensional vector because the array size is 2. Okay. Now, I can compute the theta, the angle between them, and get a value of cos theta. Hey, I hope you remember cos 0 is 1, is it? Cos 0 is 1 and cos 90 is 0, is it? Okay. So the scientists have found that if cos theta, the theta value, if it is near to 0, the value will be higher. So if the cos theta between these two vectors is less, that means as theta is less, the cos theta value will be higher, right? That is called as cosine. Cos is nothing but cosine, right? If I can somehow get the cos theta between these two vectors, and let's assume that cos of, I can represent like this, cos of A comma B, that means between A and B. If it is, let us say 0.95, for example, if the theta is less, the value will be near to 1, right? I can say that this two vectors are 95% similar. This is called as cosine similarity. There is some mathematics behind the scenes. The data scientists have identified that if you can somehow find the cos theta between these two, you'll get a value. This is called as similarity score. I can say that A and B in this case are 95% similar based on the cosine value. That means I can say that these two strings are 95% similar based on the array. But how to generate, how to convert this string to numbers, string to array? Again, there are models. There are models, predefined models who have been trained with a lot of sentences. If I give to this model, this is a model, a trained model, to this, if I give any sentence as input, it will give me a array. This model, what it is doing is, it is representing this text. It is embedding this text into this array of numbers, embedding the meaning of this text. The meaning of this text is embedded into this vector. So such type of models which can actually take a string and embed them into a vector, these are called as embedding models. There are different kinds of models. Large language model is what we are discussing, but there are some pre-trained embedding models. If I just give a string, it can give me an array, right? Yeah, I can see some questions here. I will actually take the questions after I come to a logical conclusion. Yeah, please wait. I will take all of your questions. Maybe I think everybody is posting the questions in the chat, but I will see the question and answers section after I'll complete this logical section. Okay, let me continue. So if I give a string to the model, it can convert it to a vector. Any model which can embed the meaning of this string into this array of numbers is an embedding model. There are a lot of embedding models. We can use any of the embedding model. But what is the output of this embedding model? It is an array, right? What I did is, in earlier scenario, if this is an array, I tried to plot this in a two-dimensional graph. I tried to plot this in a two-dimensional graph because the array size is 2. What if the array size is 3? I'll try to plot the same thing in 3-dimensional. What if the array size is 100? Of course, for us, it is difficult to visualize a 100-dimensional graph, but computers can visualize it. I'll plot it in a 100-dimensional graph. So different models are there. There is a model, embedding model from OpenAI. The output size of this array is 1536. For any given string, it will give an array of size 1536. Of course, if I plot it on the graph, this array is nothing but a vector, is it? I can call this array as a vector. Okay. Now coming back, okay, it is a lot of theory. Maybe coming back to the actual topic. Suppose if I give two strings, sunny day, okay, and bright day. For this, we can calculate embeddings. These are vectors are also called as embeddings, because the actual meaning of this string is embedded into this vector. There are multiple terminologies I'm using. I can call this array as a vector, also as an embedding. Okay. So I'll convert this string to embedding, and I'll convert this string to embedding, and I can calculate cos theta, as I told you. It will give me some value, let us say 0.94. This is cosine value. I can say that these two strings are 94% similar, right? Okay. Now, once you get this understanding, you will be able to clearly visualize what is a vector store. Why do we need it? How do we use it in RAG technique? Let us try to understand. It's a beautiful concept. I'll present it in a beautiful way. Now, assume that I have a PDF. Let's take a simple PDF which contains 100 pages. It contains a lot of unstructured data. Okay. What I can do is I can read this 100 pages PDF and I can create an object called as document. For each page, I will create a document. Every document will contain the page content, the first page content. Second document will contain second page content. I can write a code to read this PDF and convert it into array of documents. Okay. So 100 pages means I'll read this PDF and I'll get an array of 100 documents. Each document will be containing the page text. Okay. Then I'll make it very simple. I'll consider each document as one chunk of data. It contains some tokens, right? Token means you can consider each word is a token right now. Exactly not, but you can consider. Let's assume that first page contains, let us say, 500 words. So each page, let's assume that it contains 500 words, for example. For each chunk of text, what I will do is I'll create embedding. For this 500 words, I can create an embedding and I'll store these documents in a specialized store. We call it as vector store. Okay. So in this vector store, what it will do, what we have to do actually, how to store. I have read the PDF, 100 pages PDF. For each page, the code will create a document. That means I got 100 documents. For each document, I'll take the text, create an embedding, then store the data in the vector store. Maybe you can assume that vector store will store the data in a database table where you will have the embedding value and the data value also. Okay. So you store all the 100 documents in vector store. This data, we call it as vector database also. Vector store or vector databases are relative words. So we converted this to documents, and for each document, embedding is created and stored in the database. Fine. Now, what is advantage? Suppose if you want to search the database for some string, I want to search for, let us say, hot day. I want to search for a string called as hot day. Hot days are normally sunny days only, right? Yeah. Hot day and sunny day, for example, they mean same meaning, but they are different words. Okay. What I can do is this vector databases provide us an API called as similarity search API. What I can do, I can actually send the query, send this data to vector database and search for similar documents. So whenever we are doing a search, let me tell you what happens. This is a vector database, and this is a query. In vector database, documents are stored along with embeddings, right? Now, whenever a search has to be done, for this string also an embedding will be created. And then we will search for each document, we'll retrieve the documents who are having similarity score same as this document. I want to fetch all the documents in the database which are having more than 90% similarity score, right? So each document has an embedding, right? Whenever I do a search, I can actually query and get all the documents which are having 90% similarity score. We'll get all the similar documents. Similar, right? Okay. So vector databases are some databases which support similarity search, right? Okay, good. We understood about similarity search. Vector database supports similarity search. Now let us go on to RAG. Okay, now this is my LLM. Very interesting. Let us see. This is my LLM, and this is my vector database where I have stored all my unstructured data, whatever unstructured data I have, the PDFs, documents, CSV files, in whatever unstructured data I have stored in vector database. Remember, whenever I say that I have stored the data in vector database, we have created documents for each page, maybe. For each page, embeddings are calculated and they are stored in the database. Okay, this database supports retrieving similar documents. Okay, assume that I have a PDF which contains some written policies related to Amazon. Okay, now this is my agent, a piece of code. Whenever a query comes to agent, let's assume that the query says, I want to return a laptop. What are the written policies for laptop? This is the query. So this query is talking about written policies. Now, the agent should not send this query directly to LLM because the LLM does not know what are the written policies of our organization. The written policies are now in the database. The LLM cannot answer. So what the LLM should do is, first of all, before it sends the query, the agent has to do a similarity search on the database. Oh, my query is what? It is talking about return policy. Now my agent will use the similarity search API of the vector database and find all the documents which are talking about return policy. Let's assume that there are 3 documents in the database which are talking about return policies. So agent, whenever it gets a query, for this query, it will compute the embedding. And with that embedding, it will try to do a similarity search and find all the documents whose embeddings are having similarity search near to this one, right? Similarity score near to this one. Okay. Now agent got, let us say, 3 documents. What the agent has to do is just send a prompt to LLM. In the prompt, there should be a question, the original question, and the context. This 3 documents text will be the context. And the agent should ask the LLM, hey LLM, this is a question which I got from the user. And this is the context, whatever I got from the vector database. Now, answer this question only from the data provided in this context. So what is this agent doing? It is retrieving the data, or it is augmenting the retrieved data as a context. Send the question to LLM. LLM is generating the response, right? So basically, what are we doing? RAG. We are retrieving the similar documents, augmenting the data, whatever we retrieve as a context, and then using it to generate. So this is nothing but RAG. So most of the agents, whenever if some chatbots or so, they need to do a similarity search and retrieve the similar documents. Most of the chatbots use this technique called as RAG. Okay. So in this 1 hour, it's almost 1 hour. I made you to understand what is an agent. Agent is a piece of code for which we give tools and access to LLM. And this piece of code will take my query, talk to LLM, use the tools, and give the response. We understood what is an agent and also clearly understood what is RAG. Now using these two, let us see what all wonders we can do. Okay, I hope I was very clear. Instead of using flashy presentations, I don't prefer presentations, and I hope I'm able to explain everything on screen, and I hope you got a clear idea about what is an agent and what is RAG. So in our agenda, I just discussed about LLM as a reasoning engine, React prompting. We discussed clearly about embeddings, and we discussed about a technique called as RAG. Okay. I will do one thing. I have to just discuss about small few more things. Once I discuss, I will take all the queries at the end. Maybe I want the flow to continue. Park your queries. I hope you are actually writing all of your queries in question and answers section. Instead of me interrupting the flow, once we are at this flow, let me just discuss this, how to actually, what do I mean by autonomous agents? And why do we need a multi-agentic applications? And I'll try to compare this frameworks at a high level. In next half an hour to 40 minutes, I'll just complete this and then we'll take the question and answers. Let me make it interesting. The discussion is going on very smoothly. Let me complete this. Okay. Now, I would like to actually show you a simple code to tell how an agent can take decisions autonomously. What is the meaning of autonomous agents, right? I would like to show you a small piece of code, whatever I have. I will not go into much of coding. I will not type anything. I have some pre-built code because of time constraint. I will just explain you the code and I'll run it. Just you'll visualize how an agent can be created using a little bit of Python code. I'll be using Python for this and a framework called as LangChain. Let me just tell you how to do that. Okay, one thing, interesting thing I want to tell you. I think I have got a question also in the question and answers. OpenAI has exposed GPT. GPT is a model, and OpenAI has exposed an API. This API is not free. All right, it is, we have to actually recharge our account, and then once we have some amount as a credit in the OpenAI account, I'll be able to create something called as API keys and use that API keys in my queries from my code. My code will be making REST API calls using a particular thing called as OpenAI API key. Then we'll get the response if the key is correct and if I have credits in my account. So just to quickly show you, this is my platform.openai.com. This is, I have logged in with my account, and if I go to settings, I've got this question, I guess somebody has asked. Here, if I go to billing, I have added my credit card and I have recharged my account, and there are some $10 in my account. Okay, this is the first thing. You have to recharge your account. You have to add some credit into your account. Then what? I'll go to API keys and I can generate a key. Okay, I have generated a key already. I can just click on generate a key, give a name, it will generate a key. We have to copy that. What I have done is I have already generated a key, and I have a file called as open.env here, which is in my folder. And I have copied my OpenAI API key. This is a key which I used, and this is my key. Don't worry, I'll delete my key later. This is a key. And there's one more key also, something called as Tably API key, which I'm using here in this demonstration. These are two keys in the env. Now, I just wanted to load the .env and store that as environment variables. So very simple. I'm just using a function, a pre-built function in Python to load the .env into operating system. Yes. Okay. I told that agent can use some tools, right? So there are some pre-built tools. I'll just show you one tool of which is actually created by using a framework called as LangChain. LangChain is a framework by using which we can create agents. It's a popular framework, and LangChain has some pre-built tools. Like if you want to talk to database, there are database tools. If you want to do a web search, there are some web search related tools. So let me tell you a simple tool by using which I can demonstrate some concepts. Okay, this is a website called as tavily.com. Let me just go to tavily.com. I can connect your LLM to web. Basically, if you want to search anything in the web, Tavily has an API. Okay, I just have to create an account and log in. I have already logged in. I have an account. And again, for this, I need a key because this Tavily is exposing an API which I can call from my code. It needs a key. I have created a key, and also I have stored this in my .env. So these two keys are already loaded when I called load en. Now, if I want to use a tool from LangChain by using which we can do a search using Tavily, there is a class called as Tavily search results in LangChain community tools. I'm just showing how to use it manually. I'm creating an object of Tavily search results object. I'm saying maximum results I want is 5. And I'm asking Tavily search.invoke. Tell me about Siva Prasad Valluru. It will give me search results as a JSON, and I'm displaying that as a JSON. If I run this, see, this will make a Tavily API call, and see it is getting about myself. Maybe there is some information about myself on the web, right? From various sources, all right, and is giving me as a JSON. So this is one tool which can search the web for anything. Hey, if I ask the same query, tell me about Siva Prasad Valluru in this API. Suppose if I go to my playground, okay, what I will do is maybe I will delete all this, whatever I have. Quickly, I will delete all the entire chat. Do you think it will tell me about Siva Prasad Valluru? GPT, I'm asking GPT-4 model about myself. Let us see what it will do. I am sorry, but I don't have any information on an individual named Siva Prasad Valluru because he may not be a public figure. I'm not a public figure. So LLM doesn't know about me. But if I ask about some public figure, LLM might know. So actually, this model has been trained till 2024 July, I guess. It has information only up to 2024 July, and it has publicly available information, but it doesn't know about me because it has not been trained about my data. But if I do a web search, definitely my data will be available. So I have a tool called as Tavily, which can do a web search. If I ask Tavily about Siva Prasad Valluru, it has done a web search and it's giving URL and the content, all this. Okay. Now, let us see how to use an LLM to generate a tool call. It is very interesting. I will actually show you the necessary things. Let me actually show you how to actually create an agent which uses a React prompt. I'll directly go to the exact point, how to create a React agent. Very simple. You need a prompt agent. What I am doing is in LangChain Hub, there are a lot of prompts. There is a prompt with name HW Chase React. Okay, let me just Google for LangChain Hub React prompt. Let me just Google for React prompt. This React prompt is a famous prompt. It has been written by a person called as HW Chase, Harrison Chase. He's a founder of LangChain. So this is the same prompt which I used. Answer the following questions as best as you can. I showed you a demo, right? These are the tools. Use the following format. Question. I've used this. So instead of you writing the prompt in the code, here I pulled that prompt by using the API. I got the prompt. Then there's a function called as create react agent. I told you that agent is a piece of code to which I give my tools. Okay, so what I will do is, let me just copy this so that I can directly show you here itself. Okay. Fine. I'm pulling the prompt. I'm creating an object of OpenAI. This points to the OpenAI API. And I'm creating an array of tools. Right now, only one tool. And see, I'm calling a function, a pre-built function in LangChain. Right now, due to time constraint, I will not be able to exactly make you visualize what happens internally when I call create react agent. If I have enough time, I would have given you more detailed explanation through diagrams. But I just wanted to show a small demo through code instead of me talking. So here I'm using a pre-built function. Actually, if I had some time, I would have told you how this actually works. But let us go ahead. I'm calling this create react function. I create react agent. I told you that agent is some piece of code which has tools, prompt, and given access to LLM. So by providing all this, I got the agent. Agent knows how to talk to LLM by sending the prompts and also using these tools. But after we create an agent, some code has to execute the agent in a loop until we get the final answer, right? So as I told you in our earlier example, there is that. Yes. See, this is a piece of code or agent. Until we get the final response, it has to go on a loop and talk to LLM, right? So once we have an agent, what we need to do is we need to create an agent executor using the agent, and we gave the tools. This agent executor can internally invoke this agent. So I'm just calling agent executor.invoke, and I'm asking what is the weather in Bangalore? What is the current weather in Bangalore? See, LLM has been trained up to some past date. If I ask questions related to today's topic, current weather in Bangalore, LLM doesn't know because it has been trained only up to some past date. It cannot answer the current events, right? If I execute, yeah, can we just identify what will happen in this case? Let me draw a diagram and I'll explain. So here I have an agent. And here I have an LLM. And here I have an agent executor. Now I'm taking this agent executor also into picture. Basically, these two will go together. Internally, we build some component binding all of this, binding these two. Agent has been given tools, and agent executor also has been given tools. Both are given tools. Now what we do? We call agent executor.invoke, and I'm asking, what is the current temperature in Bangalore? Current weather in Bangalore? Agent executor will invoke agent. Agent will send a prompt to LLM. What is the kind of prompt? It is React prompt, whatever I showed you. So LLM will respond, oh, I don't know the current weather of Bangalore. Maybe you have a tool called as Tavily to do search. So LLM, as it is a reasoning engine, it tells, okay, I don't know about the current weather. Maybe you have a tool called as Tavily. What the LLM can do, it can ask you to do an action. What is the action? Invoke this Tavily tool and pass the query. What is temperature in Bangalore? Right? So LLM will give the response to agent and control will go back to agent executor. Okay. Agent executor will understand that LLM has suggested a tool call. agent executor will identify which tool to execute. In this case, it will execute the Tavily tool. And output of Tavily tool will be again passed to agent. Agent will pass it to LLM. Again, we'll get the response. Again, in this case, there's a final response. Agent might have sent the weather details. LLM will send the final response, which is given back. Right? Let us see actually what happens in this case. If I run this, I'm calling agent executor dot invoke what is the current weather in Bangalore. See what? Entering the agent executor chain. It is, you can see, I should use search engine. This is the thought. I should use search engine to find current weather in Bangalore. Action is, this is the action name. Action input is current weather in Bangalore. And actually in the logs, it is printing the result, whatever the Tavily gave. This is a result as JSON. And that JSON is sent. And here I got the final answer, current weather in Bangalore. So this is a simple demo of how to create a simple agent. Very simple, right? Very few lines of code, we are able to create an agent and get the answer from an agent. Okay. Now we understood about how a single agent can be created, right? Okay. Now I will tell you a problem with single agent. Let us try to jump into the discussion of why multi-agents are required. Okay. Why multiple agents are required? Let me tell you what it is. This is my LLM. Okay. Assume that I am a person right now. Before I go to discussion on multi-agent, I'll ask you a simple question. Let's go to ChatGPT. I'll go to ChatGPT and ask just a simple question. Tell me about Elon Musk. I am just interested in Elon Musk. I'll ask a query. Tell me about Elon Musk. It'll give me about Elon Musk. Okay, that's fine. Not normal query. Nothing much. But then I'll ask a follow-up question. Tell me about his failures. He has failed in his attempts a lot of times. I'm using his failures. Do you think I'll get the answer? I'm not saying tell me about Elon Musk's failures. I'm asking a follow-up question. Tell me about his failures. Let us see whether I'll get an answer or not. Yes, it is referencing his as Elon Musk. Okay. Now here is an important thing to understand. This LLM is exposed as a REST API, is it? It is a REST API. And I hope if you have worked with any APIs, REST APIs are stateless. That means if I send one query, the API will give answer. And if I send next query, the REST API doesn't remember your previous query. They don't remember the previous state. REST APIs are stateless, right? So for the first time, I asked ChatGPT, right? Let me tell you what might have happened. Right? This is an GPT, and this is ChatGPT. ChatGPT is an application which internally uses agents and all, right? So when I ask, tell me about Elon Musk, this GPT will be sending messages to the API, REST API. Actually, whenever whenever this GPT is sending, it can send array of messages. Right now, for the first time, when I ask, tell me about Elon Musk, only my query will be there. It will be sent. I get the response. Second time, whenever I ask ChatGPT, tell me about his failures, what ChatGPT will do is it will create an array. This is my first message. Tell me about Elon Musk. The response from the AI about Elon Musk, whatever response it got from the AI, and my follow-up question. Tell me about his failures. These 3 messages will be sent to the GPT REST API again. Because the APIs are stateless, it is the responsibility of this application to send the entire chat history. So by reading all the messages, then the GPT will understand, oh, this is the first question, this is the answer I gave, and this is a follow-up question. Now let me give the answer. So it is the responsibility of the application to give the entire chat history. Now, once you understand this, what will happen if I continue my chat for 100 or 200 or 500 messages? If you have ever chatted with ChatGPT for 100 or more than that messages, you would get an error from ChatGPT saying that your conversation is becoming lengthy. Right? Create a new conversation. You might have faced that if you have done a lengthy chat in ChatGPT. So let me tell you the problem here. Whenever I'm sending, let us say 101th message, all the previous messages, the data has to be sent in 101th message to the API, right? That means the data, whatever you are sending to the model is huge. And whenever the model has been provided with the huge data, the answering capability also will be poor. Take for an example, if I just give you one page, let's say I gave you only one page of document, I'll give 5 minutes for you to read the document, and then I'll ask you a question about that one page. Hopefully, you'll give an answer. But what if I give 100 pages document? Okay, let us say I gave you 5 hours to read 100 pages document. And then if I ask a question on 100 pages document, the probability that you will give correct answer will become less, is it? The more the data, the poor will be the response. Similarly, these GPTs, if you send a lot of data as a context, of course, GPTs will give you responses, but responses might not be so good. There might be poor responses. So better not to send huge context, too much of data. Too much of context is also not good. The GPTs will give poor response. That is one problem. One more problem is, okay, let me tell you why I told you about this. Let's assume that this is my LLM and this is my agent. Of course, assume that whenever I say agent, you have a combination of agent executor and agent. Whenever I invoke my agent executor, agent is given, let us say, 50 tools I gave to my agent. One single agent, it has been given 50 tools. It can do bigger tasks. Assume that I give 50 tools and it can do bigger tasks. Now, what might happen whenever I give a bigger task to my code? The agent will make a call to LLM. LLM might suggest, hey, invoke one of these 50 tools. Then again, the tool might be invoked. Again, another LLM call, response. So this might happen multiple times. What if this happens for, say, 30 times? 31st time, when our agent is sending, it has to send all the previous messages to the LLM. So that the LLM understands, okay, what happened in this previous 30 interactions. Otherwise, it will not remember, right? So that means if you are writing a single agent to do a complex task by giving a lot of tools, yes, of course, it is possible to get. But the problem is, if the interaction happens multiple times, the code might end up sending large context to LLM, and the responses from LLM might be poor. And also, if I have some 50 tools, when agent sends an initial question to LLM, the LLM has to select one among the 50 tools, right? Sometimes LLM also might be confused which tool to use. So it might select a wrong tool as well, right? So that is a problem with single agent. If you are actually using a single agent to perform huge tasks, these are the problems. Too many number of iterations it has to go through. big context, and giving too many tools to one single agent also will confuse the LLM and your responses might be poor. Okay. So the idea is, if you have a bigger task to be done, why do you use a single agent? You can create one agent for a particular task. So what you can do, you can create multiple agents in your code. And your code has multiple agents, one agent per task. Okay, I have multiple agents, but then how to decide which agent should execute first, then which agent should execute next, how the flow should be, right? By using LangChain, we understand how to create one simple agent. But if I create multiple agents, one agent for doing single task, single small task, just like microservices, one agent for one task. If you have bigger task, which may be divided into 10 subtasks, maybe create 10 agents. That's okay. I can create 10 agents. But how to orchestrate the flow between these agents, that will become a challenge. So when you create a multi-agentic application, how the flow should go, maybe first time agent 3 should be executed. After agent 3, maybe conditionally, I want agent 2 or agent 5 to be executed. So how to orchestrate the flow? So it becomes very complex in coding. To help us, there are some frameworks like LangGraph. There is a framework called as LangGraph. As the name says, we can create a graph of agents and decide what should be the workflow. Whenever I give a work, what should be the flow? So what we do is, in LangGraph, it's again another framework on top of LangChain. LangGraph is a framework which allows us to create a graph-like structure, maybe like this. Graph will have nodes, right? Yeah, I am almost done. We'll just conclude and take your queries. Just wait. I know some of you have raised the hands. Just another 5 minutes, I'll conclude. LangGraph is a framework which allows me to configure a graph-like structure. Each node in the graph can be an agent. This is agent 1, agent 2, agent 3, agent 4, agent 5. Like that, I can have multiple agents and I can decide the workflow. So whenever I invoke my graph, we'll say that every graph will have a start node. This is a start node. Whenever I give a task, I'll give the task to the entire graph of agents. First agent 1 will execute, and I have connected these two agents with something called as an edge. So if there's a thick edge, there are different ways to configure edges. If there's a thick edge, that means these two agents will run parallelly. If there are dotted edges, that means they will run conditionally. I can configure some conditions. After agent 2, I can conditionally execute agent 4 or agent 5. So LangGraph provides us a way to configure the workflow. You can configure agents. Maybe after agent 2 is executed, again, conditional, I might want to go to agent 1. After agent 3 is executed, conditional, I might want to go to agent 2. So I can configure conditional edges, etc. I can configure my workflow using this graph. That's how a LangGraph can orchestrate about multiple agents. So LangGraph is a framework by using which we can create a multi-agentic application. But again, you end up writing a lot of code. Of course. Using LangGraph also, you will do a low-level coding. So I felt whenever I started with LangGraph, I felt, oh, too much of code I am writing to create a multi-agentic application. I thought, if I will be abstracted from all this low-level code, and if I can just create some objects, and if I can get all this automatically done, it will be good, right? So the frameworks evolved over a period, and then I saw that there is one more framework called as Crew AI, which makes our life easier. In Crew AI, creating an object, sorry, creating an agent is just a single line code. So what they do is in Crew, as the name says, Crew AI, it allows us to create multiple agents, and we'll be able to create tasks, and we'll be able to allocate tasks to agents through code, through configuration. We configure all these agents as a crew, and we kick off the crew by just writing some simple configurations, not code. Crew AI allows us to create a multi-agentic application. Okay, I'll not go into details, but just understand Crew AI is a simple framework, very simple than LangGraph. So creating multi-agentic applications will be easy using Crew AI. And similarly, there is one more framework called as AutoGen. I like this AutoGen and Crew AI very much. These all two frameworks will provide almost similar features in a different way. AutoGen is a framework from Microsoft, a very beautiful framework similar to Crew AI. Lot of complex agents, their interactions can be simplified just by writing some few configurations and code. So these are the frameworks. Understand that these are the frameworks like AutoGen, Crew AI, LangGraph, Llama Index. They help us to create multi-agentic applications, right? So in this limited time of almost 1 hour 30 minutes, I just wanted to just give you an overview when somebody is talking about agents, right? What do you mean? How can an agent take a decision autonomously? Autonomously, I think you might have understood the agent will take the help of LLM. LLM can decide what is the next action based on the observation provided, right? So if I create an agent with the help of the LLM, the expert, it can take automatic decisions on what to do next. We can create autonomous agents, and by using these tools like Crew AI, LangGraph, and all, we can create multi-agentic applications, right? So that is about agentic AI. So basically, just to finalize, generative AI or Gen AI, it talks about generally about how to generate responses. Maybe in Gen AI, we talk about prompt engineering techniques, how to leverage various prompts. And there are a lot of tools already, pre-built tools, which is using Gen AI. And we can take or we can leverage this Gen AI by using some Gen AI tools. So when there's a course of generative AI, this might talk about various generative AI tools, how to use these tools. And in Gen AI course, normally we talk about the architectures of the models like GPT, what is the GPT architecture, what is cloud architecture, etc. And then come to a general discussion about how the models can generate, what are the prompt engineering techniques, etc. In a Gen AI course, normally we teach this. But in agentic AI, again, agentic AI also is a part of generative AI. We discuss about how to create agents, single agent, multi-agents using all these frameworks. So I hope this gave clarity about what all we can achieve. Let me now take the questions. I'll take the questions now one by one. I have some 11 questions. I'll try to answer all.
Certainly. Let me start by Himanshi's question. How to create LLM model which acts to OpenAI?
Okay. How to create an LLM model like OpenAI model, I guess. That means you want to create your own GPT? Yes, it is possible by using deep learning. deep learning is actually used for training the models. It allows us to create neural networks. As I told you, GPT, T stands for transformer, generative pre-trained transformer. So GPT is a deep learning model using an architecture called as transformer architecture. So yes, this transformer architecture papers are there. And if you learn this deep learning course, there you'll understand how to create your own model using transformer architecture similar to GPT. And you'll be creating a neural network. And you need huge data to train on it, and you get a model. Yes, it is possible.
Okay, next question. Next question is by James. If there is multiple similar word has available in database, how LLM will be give mine expected answers?
Okay. So James, okay, let me just copy the James question so that everybody can see the question, and also I'll give the answer. Just a minute. Yeah. So if there are similar words available in database, okay. So he was talking about RAG. So assume that I have a vector database, and in vector database I have ingested a lot of documents. There are some thousands of documents. Suppose if I'm searching for some words or some sentences, there might be multiple documents. Let's assume that when I searched for this document, there might be multiple documents who are having similarity score more than 90%. There might be, let's say, there are 50 documents in the vector store matching your query and having a similarity score more than 90%. Now, there are multiple things. Whenever your code is querying the vector database, we can tell what are the maximum number of documents we want to retrieve and what is the similarity score. Maybe I can say, I want all the documents who are having more than 95% similarity score to my current text. And I want you to retrieve maximum 5 documents only. So is it like filtering? There are 50 documents with 90% similarity. But I said I want documents which are having 95% similarity. I filtered out. And I'm saying only max 5. So I'll get only 5 documents which might be talking about same thing like my query. Then we did only retrieval, right? This is the LLM. This is the agent. Agent has retrieved. Then what the agent will do? It will send the question and the context. What is the context? The context is the 5 documents, whatever have been retrieved. So we'll send this question and the context to LLM and ask the LLM to answer this question based on the context. So LLM can answer only based on the context, right? Even though there are multiple documents matching our query, we retrieve only most relevant documents by specifying the search criteria, get the most relevant documents and use that as a context to get the response.
So the other part of his question was, else LLM will give multiple answers for me.
Okay, else, okay. See, if you have worked with ChatGPT, I think sometimes, James, you are saying ChatGPT you might have observed that ChatGPT can give multiple answers in two windows. I guess you might have observed that. That is ChatGPT. ChatGPT also is an agentic application, right? But model, if I talk about only model will give us single answer only. Okay.
Oh, understood. Another question from Himanshi only. I'm trying to gather the questions together so you can give a comprehensive answer.
Okay.
There are 3 parts to a question. Any other methods of similarity search other than Conce, which are popular?
Okay. Okay, let me answer this. Yes, there are other methods other than cosine similarity. There are other methods which are used for achieving, for for doing similarity search. Yes, there are other methods, but 95% of whatever I have used or whatever I have seen, 95% we use cosine similarity. That's the most popular method. But yes, to answer your question, yes, there are other options also, which I don't remember right now, but maybe you'll get it. But there are.
Wait, there.
Yeah.
Sorry, Siva, there are a lot of questions.
No,
One is, okay, does OpenAI provide free API for practice?
no, Himanshi. It does not provide free API. If you want to practice, it is charged. It is earlier, like say 1 year back or even 1.5 year back, they used to give some free credits. But now there are no free credits. You have to actually recharge. But that said, OpenAI is not providing. You can go with Google Gemini. Google Gemini provides you free API access for some basic models. Again, if you want to query big models, again, it is chargeable from Google Gemini also. Google Gemini provides you free access to only limited number of models. But again, those models are not so good. Those are basic models.
Great. What is Playground? Is it different from ChatGPT?
Yes, yes. A playground, if you see, just a minute. Yeah, if I just go to ChatGPT is different. Playground, whatever I was using is different. This is actually, if you want to send a query, you are selecting a model and you are sending a query, right? If you want to use Playground, you need to actually recharge your billing account. You have to add some credit into your account, then only you will be able to use Playground. Playground is basically whenever you are creating prompts, right? To create better prompts, you use Playground to test your prompts, right?
Great.
Yeah.
So the next question, so whenever we have to create an agent and purchase search engine, we have AI in my hand, correct?
Sorry, I think.
If we use multiple agents, can we reduce LLM? You please give overview from end user to AI working method with some diagram. Very
Okay.
short, because there are a lot of
Yeah.
questions.
Let me just take one by one. So first question I'll say, so whenever we have to create an agent and purchase search engine, we have AI in my hand. Purchase search engine, you mean to say, I guess, Tavily API, right? Yes, you can create an agent using Tavily, etc. But you have to write your code, right? AI is in your hand. ChatGPT or models are free to use. But in case if you want to use it through code and you want to automate, you need API key. So for OpenAI, you need to purchase API key. For some tools like Tavily, you need to purchase API keys. Of course, Tavily is free up to some extent. And I'll take next question from James only. If we use multiple agents, can we reduce? James, actually what? Whenever we are creating a multi-agentic application, it is sometimes like there might be a flow we have to configure. One agent one is executed. If we want conditionally, we might want to go to either agent 2 or agent. Once it comes to agent 2, maybe I want agent 4 and agent 5 to execute parallelly, maybe to get the response from LLMs, right? So yes, if you can configure parallel execution, otherwise by default, it will be a sequential execution. So if you are having multiple agents, it is only for breaking up your task into smaller tasks, right? But that does not reduce your LLM response time. No. Okay. James again, I guess. Can you give overview from end user to AI working method? I think I have given this. And from end user to AI working method. Yes, I think I have shown you the code as well, right? Yeah.
Next is it it's help to understand and remember easily? Does it help to understand and
I think he was asking about the same follow-up question. Yeah.
Yeah. Next is by Anonymous. Are these training methods of agentic AI models different to Gen AI models? If so, what are the major differences, particularly in terms of data requirements? I think you covered it in throughout
Yes,
the presentation. Yeah.
yes, yes.
Yeah. Next is by Yamuna. I am
Uh,
working on a project using Crew AI multiple agents. I'm using Chat OpenAI to create LLM.
hmm.
It is taking time to respond. What are the various strategies to enhance the speed?
Okay, Yamuna, the one thing I have used Crew AI, and the thing is, if you write your prompt correctly, if you guide the agent properly, then it will reduce the number of LLM calls. Otherwise, when using Crew AI, I also have observed that Crew AI will result in multiple LLM calls. Maybe if you don't write your prompt properly. Suppose, let's say you are talking to database, your agent is talking to database. You have to be very clear in your prompt. Hey, whenever you are talking to database, in your prompt itself, if possible, you can tell what are the relevant tables and their schemas. Otherwise, what uh, Crew AI agent will try to do? First, it will fire one query to retrieve the table names. Again, it will try to retrieve the schemas. Then again, it will try to fire a query. If the query is wrong, it will do a retry. But if you write your prompt and describe your scenario correctly and what to do, just like I'm a layman. To layman, if you have to explain me a problem step by step, how you would explain to a layman? If you do the same thing in your prompt clearly, then you can avoid multiple LLM calls from the agent, and that would improve your response time. Everything isn't prompting, you have to write clear prompting.
Great. I think there's this one last question which has come up. Himanshi is asking herself, thank you, Himanshi, for asking question, but why does the question go to you? So basically, I think a lot of people have joined from the same user as Himanshi,
Okay.
because of which all everyone's question is coming as Himanshi. They all have joined using the link, which was supposed to be only for Himanshi, and they did not join through their own registration link. That's what I understand.
Okay.
Correct me if I'm wrong.
I guess yes.
There are two questions. What is the difference between Copilot, Agent AI, tools?
Ah. So what is Copilot? Copilot actually, I can say Copilot is an agentic application. It is a multi-agentic application which internally uses the LLMs. I hope if you have used Copilot, you can select what LLM you want to talk to. Copilot is an agentic application which internally can talk to multiple LLMs as per your configuration. And Copilot can be configured as a plugin to, maybe if you are using VS Code as your IDE, you can install it as a plugin to your VS Code. So it will sit within your a development environment like VS Code or PyCharm, whatever you use. It will sit within your environment, and it can actually, maybe you can point that Copilot to your workspace. It can read the code from your workspace and answer your contextual questions automatically, because it is sitting within your development environment. It can get the context from your code and it will answer your relevant questions. So Copilot
Great,
actually is nothing but an agentic application which is sitting within your IDE to help you in your programming.
great. I think might be just the last question. Chats we are not entertaining as such, but still I'll answer one chat. There's this one question from which for which you will have to be politically correct or not. That's your choice, Siva. From your experience, which is the best framework to start with?
To start with, actually, I would say, if you want to write any good agentic application, your fundamentals have to be clear. Then only you can use a higher level framework easily. So I would start with LangChain, because when you are working with LangChain, your concepts will be clear and you will be working at a low level. So you understand what agent actually does internally. Then go to LangGraph, again, which is an extension to LangChain. You'll understand how to create multi-agentic application. Then only you go to Crew AI or AutoGen, which are high level. Because if you directly go to Crew AI, of course, you can get the tasks done very quickly, but you will not understand what is happening behind the scenes. And if you face any challenge, you'll not be able to fix that easily. But I suggest if you want to learn, you start with LangChain, then LangGraph, and then select any things like CrewAI or AutoGen, etc. And mostly in real-time projects, we use a combination. Nobody uses only CrewAI. We use a combination of CrewAI with LangChain, LangGraph, and maybe Llama Index also. Llama Index also is very good for RAG applications. So we actually use a combination. So always better to start with LangChain, then LangGraph, then go to CrewAI or AutoGen.
Great, great. I think you answered Chilakala's question also about the same thing. Launching and Crew AI are used for same purpose. That is also answered. This is one for everyone else. I request you to please email the questions to us because we are short on time and there are a lot of people waiting to win the voucher, etc. Also, though it is a very enlightening session, but yeah, we need to be considerate about everyone. Again, this is a edTalk, which is a webinar. So we do have a full program for this also with Siva. Reach out to us. We will try to schedule it for your organization, try to entertain you, and that's how edForce works. But for now, one thing which was being asked, Shiva, are you running any program or course? So certainly you can reach out to edForce. We can certainly help. Siva works with us and helps enterprises upscale. There are a lot of enterprises who have been benefited by the same. Great. So, Siva, it seems there were very enthusiastic participants who were just waiting for you to answer. Uh, while everyone's here, let me just do one thing.
Do you want to share the screen?
Yeah, I'm sharing the screen. That's okay. So let me. I hope you guys can know that why do we organize edTalks, and this has been useful for us and for organizations to get a flavor on the latest technologies. And that brings us to the end of an incredible talk. We have explored fantastic world of agentic AI and its real world applications. A huge shout out to all of you for being such an engaged audience. Your questions, participation, and curiosity made the session truly dynamic. Hope this session has sparked a new idea insights for you. If you still have questions, feel free to reach out. We are always happy to help you on our learning journey. And now, the Amazon giveaway you had been waiting for. If you are joining us from India, you have a chance to win 1000 rupees Amazon voucher. Here's how, mentioned on the screen. Leave a review on Google, follow us on LinkedIn and other social media platforms, share screenshots on my email address mentioned on the screen. You will also be getting an email with more details about it or complete details about it. So don't worry about it. But yeah, if you have won it before, please don't use this or edit the old review in the past. Finally, a special thanks to our speaker. A huge thank you, Siva, for leading us through this session. Your expertise in autonomous AI agents has given us all a fresh perspective on the future of AI-driven automation. Siva, it's been an absolute pleasure.
Thank you.
What's next? Before we wrap up, here's something exciting. Our next edTalk is happening on 24th April. We will be diving into LLMs Unleashed, exploring AI capabilities beyond ChatGPT by Hitesh Motwani. Thank you. Thanks a lot, Shiva. Once again, thank you all and Siva for being a part of this amazing learning experience. We look forward to seeing you in our next session. Until then, keep exploring, keep learning, keep innovating. See you soon.
Thank you.
Thanks, Siva.